For this problem, first let us write the coefficient matrix which is given in the problem to start with. The coefficient matrix A equal minus 1, 4, minus 4, minus 1. The characteristic equation that will give us the eigenvalues is given by lambda squared minus the trace minus 2 lambda plus determinant, which is plus 1, plus 16. Okay, so this gives us lambda squared plus 2 lambda plus 1 plus 16. And this is clearly equal 0. Lambda plus 1 squared plus 16 equals 0. Lambda plus 1 squared equal minus 16. Lambda plus 1 equal plus minus I square root of 16 plus minus 4I. So the roots are minus 1 plus minus 4I. Again, this is just playing a little bit with algebra, so I use some algebra here. Okay, so some may wonder, what if I want to do the quadratic formulas? Fine, so let's do it another way. So we have lambda squared, so this is the original equation, plus 2 lambda plus 1 plus 16, that's 17, equal 0. So lambda equal, from the quadratic formulas, we have just to be careful about the numbers, minus 2 plus minus, so the 2 squared, that's 4, minus 4 times 17 over 2. So lambda equal minus 2 plus minus square root of, so 4 times 17, that's 68, divided by 2, lambda equal minus 2 plus minus square root of minus 64 over 2. Okay, lambda equal minus 2 plus minus I for the square root of minus 1, square root of 64, that's 8 over 2. And once I divide by 2, I will get plus minus 4I again. So it doesn't matter, it's just sometimes it's easier to see some. So we are in the complex case basically. Okay, so next we try to find the eigenvector and then find the two independent linearly solutions, linearly independent y1 and y2, and we're done. But again, here there are two ways. Either we know the answer, okay, so let's say, for example, we know the answer for the general solution. Huh? So here, so the general solution, if you memorized it, so you have your alpha, it's equal to minus 1 plus 4I, therefore the real part, alpha is equal to minus 1, and beta is equal to 4. Remember, there is no I in beta. Beta is a positive number, the imaginary part. And if we go back to the matrix, we find that A is equal to minus 1 and B is equal to minus 4. So the general solution is given by, first of all, let's find y1 and y2. So y1 is equal to E alpha t, E minus t, times B cosine beta t, so it's minus 4 cosine 4t. And at the bottom we have alpha minus a, so it's 0, times cosine beta t minus beta, minus 4 sine 40. And since I can put the minus 4 outside, Okay, I can ignore it because we're going to do c1y1 plus c2y2. So this gives me cosine 4t and sine 4t. So we found y1. So what about y2? y2 is e minus t, b sine 4t, and then at the bottom we have alpha minus a, which is 0, time cosine beta t plus beta 4 cosine 4t. So again, we can put the 4 outside, and this will give us minus sine 4t over cosine 4t. Okay? So your general solution y is equal to c1 y1. So we can ignore, as I said, we can ignore the constant in the front because we are going to multiply by c1 and c2 anyway. Okay? So we have c1 e minus t times cosine 4t sine 4t plus c2 e minus t times minus sine 4t cosine 4t. So this is a general solution that gives you all the solutions of the system. Another way if we don't know the formula, okay, if we don't know the formula for y1 and y2, then what we do, we start with lambda complex, which is minus 1 plus 4i, and then we look for the eigenvector x1, y1, which is a solution to the system a minus lambda, which is a is minus 1 minus lambda plus 1 minus 4i x1 plus b minus 4 times y1 equals 0. And then the second equation is c, which is 4x1 plus d minus lambda, which is minus 1 plus d, and then minus lambda, which is plus 1 minus 4i y1 equals 0, which gives me minus 4i x1 minus 4y1 equals 0, or y1 equals minus I x1. And the second equation is exactly the same. You're going to find x1 equal I times y1 from the second equation. So anyway, so the vector now becomes is equal to x1 minus I x1 or x1 1 minus I. Okay? So in this case, we can ignore the x1. The solution, the complex solution is e lambda t minus 1 plus 4i times t times 1 minus 1. This is the complex solution. Okay? So now we need to find the real part of this one and the imaginary part of this one. So this is equal e minus t, okay, e 4i t times 1 I. So let's call this one y complex. Okay? So y complex equal e minus t e 4i t minus I e 4i t. Okay, and now we need to use Euler's formula, y complex equal e minus t cosine 4t plus I sine 4t. And at the bottom is going to be minus I times I, that's plus, so it's going to be sine 4t minus I cosine 4t. And then, of course, doing some linear algebra, to find the real part and the imaginary part, I will find e minus t cosine 14 sine 14 plus I e minus t sine 14 minus cosine 14. So as you can see here, this is your y1 and this is your y2, and you finish as c1y1 plus c2y2 at your general solution. But as you can see, we found the same. The y2 we have found before is the opposite of this one, but up to a constant is exactly the same.